Okay, hope you forgive me, but on number 4 here I seem to have forgotten what the problem is and I left a quiz at school, so we'll have to make do with what I think might be close to the problem. Either way, you get practice one way or the other. Now it's just the second way of using dimensional analysis. At first we used dimensional analysis to check if the equation was correct. Now we're using dimensional analysis assuming the equation is correct and figuring out what the final units are of this just by using the individualized units of what we know these to be. So we start, of course, off with what we know x to be, which is going to be meters, and that's going to be squared. I'm going to divide by velocity squared. Velocity is meters per second, but since it's squared, I distribute that out again, and that's going to be multiplied by t. You'll notice once again that I'm using these horizontal fractions, and then I'm placing my s and meters and everything appropriately so that it's very easy to see what cancels out. So the first thing that's going to easily cancel out is my s with my square down here. And I'm going to rewrite that again. Now, rewriting might seem like it's less productive or it's inefficient, but you'll notice that by doing this it makes it seem much, much simpler and you're usually able to see what's going to go on. Now let's quickly remind you that when you have a complex fraction, as you do in this particular case, that the easiest way to simplify is to multiply both sides of that said fraction by the reciprocal. That, of course, on the bottom will entirely cancel out, and on the top I will be left with s over m squared times m squared over 1. That means those cancel, and my final units are going to be seconds. So that, of course, whole gigantic thing is a measure of time. You probably could have simplified that.